If you don't have any doubt, just type no, so I will move on. One A2. Determine the distance fallen. So basically that is related to the first part. You will use area under the graph to find the distance as the object is accelerating. So an astronaut drops a feather from rest. So initially it is at rest or not moving. And acceleration due to gravity on the moon is 1.6. If there is no air, so means it will have a constant acceleration. The feather has falls for 4.5 seconds before it hits the ground. On figure 1.1, draw a speed time graph. So how basically at 4.5, what is the speed, the final speed? So we have the formula v, which is the final speed, is equals to u plus at, or acceleration is v minus u over t. That's the same formula as v is equals to u plus at. Because the object is falling objects and initial velocity is 0. So you have u plus at. Initial velocity is 0, acceleration is 1.6, and how long? 4.5 seconds, so that's multiplied by 4.5. So when we multiply these two, 1.6 multiplied by 4.5, that will be 7.2 meter per second. So when the time is 4.5, the speed is 7.2. So 4.1, 2, 3, 4, 5. So this one is 4.5 and the speed is 7.2. Each box is representing 2. So 6.2, 4, 6, 8, and 7, and then 7.2. So because it's a constant acceleration for speed time graph, the constant acceleration means straight line which is starting from origin with a constant slope. So that will be the graph. How to calculate a distance travel? If you use this formula, speed is distance over time, you will get wrong answer. Why? Because this formula is only valid when speed is constant. But in this question, the speed is continuously changing as the object is accelerating. So you cannot use this formula. Then what you have to do, you have to use area under the graph. So what will be the area under the graph? What shape it is making? It is forming a triangle. And for triangle, what we use, that's the second part. So that is half base into height. So base is equals to 4.5 and the height is 7.2. So using a formula half base into height, we will get its the distance travel, which is will come out 16.2 meters. So this was question 1. Any doubt in question 2? If you don't have any doubt, just type no. If you have doubt, mention the part in which you have a doubt. Question number 2. 2 part B. The tanker sails out onto a calm sea. The density of the sea water is greater than density of the river water. State and explain any change in the depth of the bottom of the tanker below the surface. So basically what happened, how you can relate, the first thing, the weight of the tanker is acting down. So example, we have identical tankers, same weight is there. both are floating, so it means the upward force by the sea or the water should be more than the weight, or more than or equal to weight, so it will float. Example, weight of this tanker for tanker A is 100 Newton, weight of tanker B, identical tanker, is also, or the same tanker, 100 Newton, but the first one is in a river and the second one is in the sea. So weight which is acting downward. Now what happened? The surface, the liquid will also apply a force, and that is the upward force, or the upthrust force. Upthrust means the upward force of the fluid, the liquid, that's called upthrust. So there is an upward force or the upthrust force from the water. Yeah, that's right as well. And there is an upward force from seawater as well. But this upthrust force or upward force depending on the density of the fluid. Greater the density of the fluid, greater the upthrust force. You can explain in terms of upthrust, you can explain in terms of pressure as well. Like the river is exerting, or upthrust of the river is say 110 Newton, where upthrust of the sea water is 150 Newton. So you can see here in a sea water, greater upthrust force as compared to weight. So as there is a greater upward force compared to the weight, then smaller amount of object will be there underwater. But here, this river water upthrust is smaller. So if its upthrust is smaller, greater depth or greater volume of the liquid will be there, a greater volume of the object will be there inside the liquid. So the question is, the tanker sail out onto a calm sea. The density of the sea water is greater than the density of river water. State and explain any change in depth of the bottom of the tanker below the surface. So means this depth they are asking. So what we will observe this change, as the river water, the sea water is having a higher density, so it will apply a greater upthrust or greater upward force. And due to this greater upthrust or upward force, the depth of the tanker, which is in a sea water, will be smaller as compared to depth of the tanker in a river water. Is it clear? Or you can also use the concept of the pressure. You can also use the concept of the pressure. Pressure is equals to density into gravity into depth. So to create a same pressure, if the density is higher, the depth should be smaller. Question 3. Any doubt in question 3? So for question 3, part B, Figure 3.1 shows a glass tube containing a mercury. So there's a mercury. So air is exerting pressure from this side. The pressure is due to mercury and the pressure is due to atmosphere. So what we can say pressure of the air in the left hand side column is equals to pressure of the mercury due to difference in the depth, the height, and pressure due to atmosphere. The mercury trap a fixed mass of air in the left arm of the tube. The right arm of a tube is open to the atmosphere and the difference in mercury level in two arms is given with its h. The pressure of the atmosphere on the surface of the mercury on the right hand side is 760 millimeter. The distance h is 120 millimeter. Calculate the total pressure at Q in millimeter due to the atmosphere and the mercury above it. So what is the total pressure at this point?
Sir,
Yes.
sir, what is meant by millimeter mercury?
Pressure actually
The pressure.
basically what happened due to this pressure, the mercury will rise in the tube. So how much mercury rise in the tube depend on the pressure exerted. So pressure can be represented in terms of millimeter of mercury. In a barometer, when you have a mercury barometer, so you take a container and because of the pressure of the atmosphere, the mercury will rise in this tube. So what I can say that how much mercury rise in the tube is proportional to the pressure applied on the surface of the mercury. So if I say the pressure was say 100,000 Pascal, or how much it rises in the tube, example it is 760 millimeter. So I can say the pressure is equal to 760 millimeter, but actually it is indirect explanation of the pressure. What is the meaning of 760 millimeter? It means that due to the pressure, the mercury will rise in the tube and the height to which the mercury rise, that is equals to 760 millimeter. So it is just a representation of the pressure in terms of the level, the rise or the change in level of the liquid. So when they are saying that the pressure of atmosphere is 760 millimeters. So what they mean? They mean that if the pressure is exerting atmosphere, that will cause a mercury to rise in the barometer to a height of 760 millimeter. And the distance h is 120 millimeter. So this is the height of the liquid above Q. So what is the pressure at Q? The pressure at Q is pressure due to the mercury, the height of the mercury, and the pressure due to atmosphere. So if the pressure due to atmosphere is 760 millimeter, these are also millimeter of mercury, these are also units of pressure or representing pressure in terms of height rise. And the height of this column is 120 millimeter. So the question is calculate the total pressure at Q. What is the total pressure at Q? So that will be the sum of atmospheric pressure plus pressure due to liquid. So atmospheric pressure is 760 millimeter and pressure due to liquid is 120. So that will be equal to 880 millimeters. Then state the pressure exerted by air in the left arm of the tube. So what is the pressure exerted by the air? Because it's a manometer. So pressure due to air balances with pressure due to mercury and pressure of the atmosphere. So pressure of the air is equals to pressure due to mercury, the liquid, plus pressure of atmosphere. Pressure due to liquid is 120 and pressure of atmosphere is 880. So when we solve, pressure of atmosphere is 760. So when we solve, we will get the same answer, which is 880 millimeter. So at this point, the pressure is also 880. This was also 880. So the pressure of the air is equals to pressure of atmosphere plus pressure of the mercury in the tube due to difference in the height. In the next part, this is related to thermal physics. The initial volume of the air which was trapped is 12. So that is V1. And what was the initial pressure? That was 880 millimeters of mercury. More mercury is poured into the right hand side, the volume of the trapped air decreases, the temperature does not change, the difference in the level H become 240. So if the difference here become 240, when we add more mercury, this height become 240. So what is the new pressure at air? So the new pressure at air is equals to 240 plus 760. 760 is the atmospheric pressure and 240 is due to the pressure of the mercury. So 240 plus 760. So that is equals to 'because the difference become 240. So 240 plus 760, which is equals to 1000. Calculate the new volume of the trapped air. So the new pressure is, so you will use the formula P1 V1 equals P2 V2. So P1 is a starting pressure, the initial pressure. What is P1? That is 880. V1 is the initial volume, which is 12. P2, when 240 millimeter of mercury height is there, so the total pressure on the gas is due to mercury plus atmosphere, that's equal to 1000. And V2 we don't know, so we write V2. 1000 is multiplied, other sides will divide, so it will be 880 multiplied by 12 divided by 1000. What's the answer for this? V2? 10.6. So you will write 10.6. In the marking scheme, normally the answers are rounded off, but 10.6 is the correct answer. 10.56 or 10.56 or 10.6. Centimeter cube. Any doubt in question 4? If no doubt, just type no, so I will move on. Question 5, any doubt? Five part 2. You mean B2? B1 and B2 are related, so you have to use an ice hockey rink has an area of 1800 meters square. The thickness of is 0.025. The density is 920. What is the mass? So density is mass over volume. So mass is equals to density multiplied by volume. Always write the formula, because the distribution of the marks, you will find 1 mark is for writing that formula. So how to get the volume? Volume is area multiplied by height. So density is 920 multiplied by 1800 multiplied by 0.025. So the mass of the ring is 41,400 kilogram. Then the ice at zero, to form the ice, water at zero is poured onto a floor of the ring and then frozen. The specific latent heat of fusion, it says energy required to convert solid into liquid, or it is energy released when liquid change back to solid, but for 1 kilogram or each kilogram. Calculate the energy removed. So we have the formula latent heat is equals to energy divided by mass. So energy will be equal to latent heat multiplied by mass. The latent heat is given 3.3 exponent 5, and the mass of the ring, like the total mass we need 41,400. So multiply them, you will get 1.4 exponent 10 joules. Any doubt in question 6? B2. On the figure, draw the dotted line to represent 3 rarefaction. As they mention, the wavefront, these are wavefront, not the wave. Wavefront means identical points of the wave, different wave, that is wavefront. So the wavefronts are successive compression, means this is compression, this one is compression, this one is compression, compression and compression. So between the two compressions, what I will have a rarefaction. So between the two compressions, I will draw lines, but this should be dotted lines. So I will draw a dotted line here. So these are the wave fronts which are representing the position of rarefactions. Is it clear? Because if they say draw a longitudinal wave, so then region where the particles are closer, that is compression, then particles are away, rarefaction. That is the wave. But here you don't have to draw wave, you have to draw wavefront. Means identical point which are represented by a line, we call that as a wavefront. So compressions are denoted by a continuous line in this example. So rarefactions denoted by dotted lines. Question 7. Any doubt in question 7? Question 7a. The box contained two identical glass prism. One is shown. The light incident on prism 1 and undergo total interreflection. On the figure, complete the path. So if it undergo total interreflection, it means first thing, as the light is passing along the normal, so it will pass straight. But when it strike a glass to air boundary, this angle is more than the critical angle. So it will undergo total interreflection, or you can say reflection. So it will reflect back. Then there is another prism which we have to make, and it will also undergo a total internal reflection. So how the second prism is placed? So it is placed other way around so that a light strikes the prism 1, undergo total inter-reflection, hit prism 2, undergo total inter-reflection and emerge out from other end. So this is a figure which you have to complete. Is it clear? Part A1 and A2. Question 8, any doubt? Part B, select the statement that correctly describe the necessary conditions for the light to undergo total interreflection. Take two boxes. For total interreflection, angle in the glass is less than the critical. If it is less than the critical, then total interreflection does not happen. The angle of incidence in the glass is greater than the critical. So angle in the glass is greater than the critical angle. The angle of reflection in the glass is equal to angle of refraction. That's wrong. The speed of a light in a glass is greater than speed of light in air. That's also wrong. The speed of a light in glass is equal. That's also wrong. And speed of light in glass is less than speed of light in air. So tick two boxes, only the boxes which you have. No, the reason why I'm putting a cross, just explaining the idea. You don't have to put cross. You just have to tick the two boxes. But I was discussing, that's why I was putting a cross to explain which one is not a correct statement. Question 8. Incident passes along the normal if angle of incidence is 0. As you can see here, when I draw the normal, if I draw the normal and the incident are in the same direction, or when the angle of incidence is 0, that time angle of refraction will also be 0, and light will only change the speed, but it does not change the direction. In question 8, calculate the energy transfer in 40 minutes. What is the formula for energy? Electrical energy or any kind of energy is power multiplied by time. And what is power? P is equals to VI. So voltage into current into time. But in this question, we have the EMF. We have the EMF of the battery because calculate it is made up of 8 multiplied by 1.5.
12,
That is 12 volts. But for the next question, we need energy transfer from the battery in 40 minutes. As we know, energy is power multiplied by time. So we can write energy is VIT. We know the voltage, but we don't, and we know the time, but we don't know the current. So if we don't know the current and we know the resistance, so how we can find or which formula for resistance? So we have the formula V is equals to which formula for current? So we have the formula V is equals to IR. So I is equals to V divided by R. Because in this formula, you have to use two different, in this question or part, you have to use two different formulas. That is why the weightage of this question is more. So V is equals to IR, I is equals to V over R. So voltage is 12 and the resistance is 8. So 12 divided by 8, that is equals to 1.5. So the current is 1.5 ampere. So now we know the voltage, which is 12. We know the current, that is 1.5. And the time, but the time is in minutes. It should always be in So time should be in seconds. So it is 40 multiplied by 60. So when you multiply all these factors, you will get the answer. 43,200 joules. Describe the energy changes that take place during the 40 minutes. So what are the energy changes? First thing, what you have a battery or a cell. So cell or a battery, which form of energy it is stored, it will have a chemical energy. And what happened? You connect to a device, as you can see in the question. We have a circuit which is made up of group of cells and it is connected to a resistor. So if this was a cell, you connect this cell to a resistor. The conventional current from positive to negative. So cell is having chemical energy, but it produces charges, so it will be electrical. But when these charges move through a resistor, it will produce heat. They lose their energy in the form of heat. So chemical change to electrical and that change to heat energy. Question number 9, any doubt? In question 9, the mover cable has a thick wire appropriate for the current and a correct fuse. The cable is too short, so that the gardener uses an extension. He is using an extension with a thin wires. So extension is there with a thin wires. Intended for use with a reading lamp, the cable has no fuse. So this cable does not have any fuse. Discuss any dangers of electrical arrangement shown in figure 9.1. What are the dangers? Can you point out any dangers? Yeah, what are the dangers in this? So it might be electric shock, or it might produce overheating because extension cables are too long. Yeah, that's right. Electric shock if it cut in insulation, exposed to or placed on the damp condition. So basically, these extension cables, it's too long. When you're using a long wire, as you know, long wire, greater the length of wire, greater the resistance. Higher resistance means it will produce more heat energy, so it might increase the chance of fire, because heat or increase in temperature. So yeah, these are the things which you can mention. Same way, like example, overheating can be there, or too much heat is produced because you are using a long wires. Electric shock, a gardener might get an electric shock in a moist or a wet condition. Thin wire having high resistance, so they produce more heat energy. And due to high heat energy, there might be overheating or a fire. Yeah, that's right. The moisture can get into, or the water can get into the wire which is cut, or so electrocution, or a person may get electric shock. So two things you will mention related to electric shock, and two things you will mention related to a fire or overheating. That's why it's of 4 marks. Question 10. Figure 10.1 shows a wire AB suspended on the two support so that between the poles a strong magnet is there. The wire AB is loosely held so that it is free to move. Describe and explain any movement of the wire when there is a current, a large DC from A to B. So if there is a current, there is a magnetic field. So when the current is passing through the wire, that wire will produce magnetic field. So how many magnetic fields are there? There are two magnetic fields. One is due to the wire and another one is due to the magnet. So the answer here, when current passes through a wire, the wire will produce magnetic field, or magnetic field of wire interact with magnetic field of permanent magnet, experience force. And how we can find the force? We can use left hand rule to find the force. So according to left hand rule, first finger represent magnetic field, second represent direction of the current, and thumb will represent the direction of the force. I'll complete this question in the next session.